Okay, so 13.3, number 8, says a half-mile ramp begins 2,596 feet from a bridge, and there is a support under a toll plaza that's located 1,500 feet up the ramp. So let's get a couple of things clear about this picture, first of all. There's a number that's not marked here for you, and that is the fact that this is a half-mile ramp, which means from here up to here is half a mile. Okay, and since the rest of this diagram is done in feet, I'm going to convert that half a mile to feet. 1 mile is 5,280 feet. So if I cut that in half, I believe I get 2640. Yes. So this entire distance up top is 2,640 feet. The other thing to be aware of is this number down here, the 2,596. It's a little misleading on the diagram. That's this entire length. So this entire length is 2,596. Okay? And it says, how far is the base of the support from the lower end of the ramp? So this here is my support. This is what they're talking about with the lower end of the ramp. So what I'm trying to find is just this distance here. So for part A, I'm looking for this piece. Again, remembering that the 2,596 is that entire distance. Well, if you think of this as a small triangle inside a larger triangle, you can set this up as a proportion with similar triangles. Okay, this x is going to correspond with the 2,596 in the bigger triangle, and this 1,500 is going to correspond with the 2,640 in the larger triangle. So my proportion would look like this. X over 2,596 equals 1,500 over 2,640. And then I'm going to cross multiply. Okay. So 1,500 times 2,596 comes out to be 894,000. And that equals 2,640x. Then I'm going to divide by 2,640. Divide by 2,640. I come out to 1,475. So now I know this smaller distance here. Let's do this. This smaller distance here is 1,475. Okay, I might need that for the next problem, so that's why I marked it in the picture. Okay, and then B says, how high is the support? So that means now what I'm looking for is the height of this support beam right here. So now this is my X. Okay? So when I look at this, my first instinct, of course, since we're talking about similar triangles, is that I want to use a proportion. However, if I'm looking for this, I'm going to need something to compare that to in the larger triangle, which would be this length that goes with this one. And I don't have that length either. So a proportion is not going to work for me. However, this smaller triangle here is a right triangle. And I know this length and I know this length. So here I can use Pythagorean theorem. Now normally, because we're in a chapter on similar triangles, I would like you to do this without Pythagorean theorem if at all possible. But this problem, that's not going to be possible because I can't set up a proportion with this side. So from here, I'm going to use Pythagorean theorem to solve for x. Okay? So I would say 1,475 squared plus x squared is equal to 1,500 squared. Okay. Again, looking at this right triangle, the 1,500 is your hypotenuse. Okay. I'm going to do this kind of all in one big chunk here. I'm just going to take 1,500 squared, just because I don't want to take the time to write down all these big numbers. 1,500 squared and just subtract 1,475 squared, all in one shot. That comes out to 74,375. So then I end up with x squared equals 74,375. Then I would take a square root of both sides, and I end up with 272.7. Okay, so that's it for problem number 8. Again, I would not count on being able to use Pythagorean theorem in a problem like this one. This one was just a little strange that it had this x here without giving you a number for this side over here.